In this video, we're going to learn how to find the slope of a line graphically. The term slope refers to the steepness of a line. The steepness of a line is a ratio of the rise to the run, or in other terms, it's the ratio of the vertical change to the horizontal change. Okay, slope is also known as the rate of change. Okay, so you might hear slope and rate of change used interchangeably in certain questions. Okay, so again, slope is the rise to the run, it's the vertical change to the horizontal change. On a graph, you always analyze the line by reading from left to right. And if a line that's diagonal on the graph has, a line that's diagonal on a graph either has a slope that's positive or a slope that's negative. If the line is increasing as you move from left to right, then the slope is going to be positive. But if the line is decreasing from left to right, then the slope is going to be a negative number. Okay, and so if we look at the two lines that we have graphed underneath, again, you're going to analyze them by moving from left to right. What's happening to the line as you go from left to right? In this first graph, okay, as we move from left to right, the line is going to be decreasing. Okay, so what kind of a slope does this line have? Well, if the line is decreasing as you move from left to right, then the slope is going to be negative. This is a negative slope. Right? For this line right here, as we move from left to right, notice that the line is increasing. Therefore, this slope is going to be positive. Okay, so these are examples of what a negative slope would look like and what a positive slope should look like. And again, slope represents the vertical change over the horizontal change, which is the ratio of rise to run. All right, rise goes vertically, the run goes horizontally. All right, rise over run. So what we're going to be doing here is finding the slope of a graphed line, okay? And slope is always represented by the variable m, okay? So in a question where it says what's the value of m or m equals, they're talking about the slope of the line. And again, m, the slope, is the rise over the run, and the way that we find that is by finding the vertical change over the horizontal change, okay? This symbol right here is the symbol delta. And delta means change in this example. What's the change in the y values, which again, that's the vertical axis, over the change in the x, which is the horizontal axis. The vertical rise over the horizontal run. That's what we're going to be finding here when we have a graphed line. So the box here lays out the steps that we're going to follow. If you have a line that's already been graphed, then you can easily calculate the slope of the line by using the following steps. The first thing that you need to do is identify 2 points that are on the line. Make sure that the coordinates of each point are integers. So let's take a look at our first graph down here. I've got this line here, and moving from left to right, the line is increasing, so I know this slope is going to have to be positive. All right, so what I'm going to do is find 2 points that are on this line, any 2 points that have nice integer coordinates. I'm going to use this point here, and I'm going to use this point right here. Okay, these are 2 points that are on that line. Okay, what I'm going to do, I'm going to start from the point that's furthest to the left. Okay, and in this picture, that's going to be this point here. This point is further to the left than this point is right here. So I'm going to start with this point right here. And I'm going to count the vertical rise until I reach the height of the second point. All right, so here I am. Here's my first point, and I'm going to rise vertically until I get to the same height as this point right here. So I'm just going to rise straight up until I get to this point right here, and I'm going to count how much that is. So starting here, I moved straight up 1, 2, 3, 4 units. All right, so when I'm doing my slope m, it's the vertical change, delta y, over the horizontal change, delta x. And the vertical change that I just counted here, straight up, I went 4 units up. Okay? Now I'm going to figure out in step 3 the horizontal run until I reach my second point. Okay, so I started here, I rise, or I've gone up 4 points vertically, And now I'm going to count over until I get over to this point found right here. So here I am. I'm going to count 1, 2, 3, 4, 5, 6, 7, 8 units to the right. All right, I move to the right 8 units. So my horizontal change, delta x, is going to be 8. And now all I need to do, all right, I've substituted both numbers into my slope ratio. Now I'm going to simplify. All right, my slope here is 4 over 8, 4/8, which I can simplify down to 1/2. So the slope of this line right here, m equals 1/2. And here's what that means. Right? The slope tells you how to get from point to point on your line. All right, I'm going to start on a point, and I'm going to rise vertically 1, and I'm going to move to the right 2. Up 1, over 2 to the right. Up 1, 2 to the right. So if I start here, I go up 1, 2 to the right, and it gets me to this point on the line. I go up 1, 2 to the right, and it gets me to this point on the line. Up 1, 2 to the right, up 1, 2 to the right. Okay, so that the slope tells you how to get from point to point on your line. Okay, so the slope of this example, this slope is 1/2, rise 1, run vertically to or horizontally to the right 2 spaces. Here is my next graph, and as I move from left to right, notice that this line is decreasing, so when I find the slope, it should be a negative number. So the slope m equals delta y, which is the vertical change, over delta x, which is the horizontal change. Notice that 2 points have already been plotted on this line. All right, so I'm going to start with the point that's furthest to the left, which is this one. And the first thing I'm going to do, I'm going to move vertically until I reach the same height as my point on the right. So since this point is higher than this point, I'm actually going to be moving vertically down. So I'm going to move straight down until I get to the same height, which is at this point right here. So I'm moving down 1, 2, 3, 4, 5, 6 units. And since I moved down, that's going to be a vertical change of -6. Now I'm going to count from this point horizontally until I get over to this point, which moves me to the right 1, 2 spaces. Moving to the right is +2. So my slope is -6 over 2, which simplifies to -3 over 1, which is just -3. All right, my slope m of this line is -3. Okay, so again, this tells you how to get from point to point. I'm going to go down 3 to the right 1, down 3 to the right 1, down 3 right 1 gets me here, down 3 right 1 gets me here. So the slope of this line is -3. Here's another line that's decreasing as we move from left to right. So again, this is going to be a negative slope. And again, 2 points have been plotted. We've got this point here and this point here. M equals delta y over delta x. So let's get the vertical change first. Again, this is the point furthest to the left, and it's higher than this point on the right, so I'm going to have to move down until I get to the same height as my point on the right. So I'm going to move down 1, 2, 3, 4, 5 spaces. Moving down is -5. Now I'm going to move to the right until I get to my second point. I moved right 1, 2, 3 spaces. The horizontal change is 3. All right, and so my ratio is -5/3. That doesn't simplify, so I can just say the slope of that line, m equals -5/3. And again, this tells you to move down 5 and to the right 3. Down 5, right 3. That would get me from point to point on that line. In my next picture, I've got this line right here. Now notice that this isn't a diagonal line like we had in all the other examples. This is actually a horizontal line. And to figure out the slope of this line, I'm again just going to find any 2 points that are on the line. It doesn't matter which two. So I'm going to pick that point there. I'm going to pick that point there. All right, and again, to calculate the slope, m, you have to do the vertical change, delta y, over the horizontal change, delta x. And the first thing we're going to do, we're going to move vertically until we're at the same height as the point on the right. But notice that these 2 points are already at the same height, so I don't need to move vertically at all. So my vertical change delta y is going to be 0. Now I'm going to count horizontally until I make it over to my second point. I'm going to move to the right 1, 2, 3, 4 units. And so my slope is 0 over 4, which is just 0. Okay, the slope of a horizontal line is going to be 0. because there is no vertical change in this line. This is a nice horizontal line. It doesn't change vertically, so my slope is going to be 0. Compare that to this vertical line that we see right here. To calculate slope, again, m equals delta y over delta x. Let's pick 2 points, any 2 points on that line. Let's use this point and this point. All right, the first thing that we're going to do is figure out the vertical change. So if I started at this point, I would have to count up 1, 2, 3, 4, 5 units. My vertical change is 5 units. Now, if I started here, I would have to count down 5 units, so I would put a -5 there. This isn't actually going to matter because now, when I look at the horizontal change, notice that these 2 points are on the same vertical line. I don't have to move horizontally at all, meaning that the horizontal change is 0. And if you remember, the denominator of your fraction is never allowed to be equal to 0. So 5 divided by 0 is actually mathematically impossible, and we say that this is undefined. Okay, and that's going to be true of the slope of any vertical line. The slope of any vertical line is going to be undefined. So in our last two graphs, we had a horizontal line and we had a vertical line instead of a diagonal line. A horizontal line will always have a slope of 0 because there is no vertical change in the line. A vertical line, though, will always have a slope that is undefined, and that's because there is no horizontal change or delta x for that type of line. Okay, meaning that the denominator of the slope ratio would be 0, which always leads to an undefined answer. So these are special slopes. If you have a nice horizontal line, your slope is going to be 0. There is no vertical change, all right? It's a nice straight horizontal line. But if it's a vertical line like this, okay, the line is vertical, the slope is undefined. There is no horizontal change in this line. Let's practice finding the slope of our graphed lines. In our first graph here, notice the line is decreasing as you move from left to right, so this slope should be negative. And I've got two plotted points that I'm going to use. So again, the slope m is delta y over delta x. So the first thing we need is the vertical change delta y. Starting from the left, I'm going to move down 1 unit because that'll get me to the same height as the point on the right. Moving down 1 unit is -1. And now I'm going to move horizontally to the right until I make it to the other point. 1, 2, 3 units. The horizontal change is 3. And so my slope here, m, equals -1/3. I would move down 1 to the right 3, down 1 to the right 3, and that would get me from point to point on that line. In my next picture, again, this line is decreasing as you go from left to right, so the slope is going to be negative. M equals delta y over delta x. And for the vertical change, here's my point on the left. It's higher than the point on the right, so I'm going to move straight down. And I'm going to move down 1, 2, 3 units to get to the same height as this point on the right. So moving down 3 is -3. Now I'm going to move to the right till I make it to my second point, and I move 1, 2 spaces to the right. So the horizontal change is 2. And this ratio can't be simplified, so the slope here, m, equals -3/2. I would go down 3 and to the right 2, down 3 to the right 2, in order to get from point to point. Our next graph, again, decreases as you move from left to right, so the slope here is going to be negative. I'm going to use these two plotted points to calculate my slope m equals delta y over delta x. And let's get the vertical change first. All right, I'm going to move down until I get to the same height as my second point over here. I went down 1, 2, 3, 4, 5, 6 units, so that's going to be -6 as my vertical change. Now I'm going to move to the right 2 units to make it to the second point. -6 over 2 is the same as -3 over 1, which is -3. The slope here, m, equals -3. Again, I would have to move down 3 and to the right 1 to get from point to point. down 3, right 1, down 3, right 1. My next picture, my line is increasing as I go from left to right. So I'm going to have a positive slope this time. M equals delta y over delta x. Let's get that vertical change. So here's my point on the left, and I'm going to have to move vertically upward this time so that I can get to the same height as this point over here. I moved up 1, 2, 3, 4, 5, 6, 7 units. And now horizontally, my change is going to be 1, 2, 3 units to the right. 7 over 3 doesn't simplify, so the slope here, m equals 7 thirds. Here's our next graph. The line's increasing as we go from left to right, so this is a positive slope. They didn't plot any points for us, so let's find any 2 points on that line. I see this point right here, and I see this point right here. So those look like 2 good points that I could use to figure out the slope of the line. And now again, we're going to set up our slope formula. M equals delta y, the vertical change, over delta x, which is the horizontal change. Okay, so we're going to start with the leftmost point, all right, and that's going to be this point here. And what we're going to do, we're going to count up vertically until we reach the height of the second point. So I'm going to move straight up until I reach this height right here. So let's count up 1, 2, 3, 4, 5, 6, 7, 8 units. That's the vertical change. And now we're going to move to the right until we make it to the second point. 1, 2, 3 units to the right. 8 thirds is our ratio. It doesn't simplify, so our slope here, m equals 8 thirds. My second point over here, again, 2 points haven't been plotted, so I'm going to figure out any 2 points that are on that line. All right, let's go with this point right here, and let's go ahead and use this point right here. All right, so the line's decreasing, moving from left to right, so the slope here is going to be negative. M equals delta y over delta x. Let's get the vertical change first. My left point's higher than my right point, so I'm going to move straight down until I reach the height of the second point. I went down 1, 2, 3 units, so the vertical change is negative 3. Now I'm going to move to the right 1, 2 units to get to the second point. Okay, and this ratio again doesn't simplify, so our slope is negative 3 halves. I would have to move down 3 and right 2. Down 3, right 2. Down 3, right 2. And that gets me from point to point on the line. All right, so let's look at our next line. It's increasing, so I'm going to have a positive slope. Let's find 2 points. I like that point right there and that point right there. So m equals delta y over delta x. Let's get that vertical change delta y. We're going to move straight up to get to that height there. 1, 2, 3, 4 units up. And then we're going to move horizontally to the right. 1, 2, 3 units for our run. 4 thirds doesn't simplify, and so that's our slope, 4 thirds. Our next graph, the line's decreasing, moving from left to right, so we're going to have a negative slope, delta y over delta x. And again, let's find 2 points that are on the graph. So I like that point right there. And then we've got another point down here. And let's figure out what the change is going to be. All right, I'm going to have to go down vertically to get to this height here. 1, 2, 3, 4, 5 units down is negative 5. And now move horizontally to the right. 1, 2, 3 units. And there's our slope. That doesn't simplify. M equals negative 5 thirds. Our next line here, notice, is a horizontal line. There is no vertical change here. And when there is no vertical change, then the slope of a of a horizontal line is always 0. Okay, so that's a nice one for us, right? If we have a horizontal line, there is no slope, the slope is 0. Looking at this one, increasing as we move from left to right, this will be a positive slope. M equals delta y over delta x. And let's see if we can get the vertical change. Let's find some points that are on that line first, all right? I'm going to use that point right there and that point right there. So vertically, I'm going to move up, and I moved up 2 units. Now horizontally, I'm going to move to the right, and I went to the right 1, 2, 3, 4 units. So the slope is 2 over 4, which simplifies to 1 half. M equals 1 half. And so to get from point to point, I go up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2, etc. Here's the graph of a vertical line, and with a vertical line, there is no horizontal change, which is the denominator of your slope ratio, which means the denominator is going to be a 0, which can't happen. And that means that the slope is undefined. The slope of any vertical line is going to be undefined. All right, in our next picture, our line is decreasing as we move from left to right, so this should be a negative slope. Let's see if we can figure out what that is. M equals delta y over delta x. And let's find a couple of points that are on that line. I see this point right here, and I see this point right about here. That looks like a good one. Okay, and now let's see if we can figure out that vertical change. I'm going to move downward until I get to this height here. All right, so we went down 1, 2, 3, 4, 5, 6, 7, 8 units, and that's going to be a negative 8 since we went downward. And now I'm going to move to the right until I make it to this point here, 1, 2, 3, 4, 5 units. And that ratio doesn't simplify. So the slope here is going to be negative 8 fifths.